Now, I need to correct myself because I sitting here really looking at what they did. I'm actually wrong. So we got a call that this Voyager is not coming on and running. I need to get it opened up. We found the VFD went bad, and now we're tripping some alarm issues. I'm not sure. We've done quite a bit of work on this system already, so I need to inspect the drive. This is my first time putting eyes on it myself. I've had a couple of different guys working on it up to this point. So this got replaced. This was the drive that was failed. It was tripping on an earth fault, and we verified the motor was good. We disconnected the motor from the drive, and even without any motor leads attached to the T terminals, it was still tripping on an earth fault internally. So put the new drive in. That's good to go. I like that for a nice return. Woo! Imagine falling down in that. And they were saying that the other day when they were here, the automation was tripping out. Now this should be my start-stop relay if I'm not mistaken. And it is not closing. I may be mistaken though, so I'm not the most familiar with this building. Kind of figuring it out as I go. I know this is our communication, I believe. There's our controls. So deadband 0.2, set point 1.5 inches. That's way higher than I want it to be, but whatever. Morning warm up. Supply air is about 55. So 17 and 16 I think are communication. This is tied to a Summit 3. Okay, well these are hooked up to a VAV system. So I need to go down, check the automation, and see if that has us locked out in any way, and go from there. So I want to put out there, I really encourage y'all to go look at Trade Academy Scholarship. I was talking to their team just yesterday, and they were telling me that they've got less than 20 applicants so far in for that scholarship. You realize that they're looking for 10 people to give that scholarship to. They've got $25,000 they're looking to give away for 2021. I really encourage y'all to go out there. If you're needing a scholarship to either get into school or get through school, just go apply. It's really simple. It's really easy. I've got links in the description on how to do so. They're really trying to help, be a part of the process to get this trade back online. As well, there's also going to be a giveaway, and I'm planning to make an announcement on Saturday's video for this week's giveaway. So I definitely encourage you to stay tuned for that. Look for Saturday's video for that information and details on that giveaway, and we'll go from there. So we do show an alarm. Clear it from here. Try to get it back on. It had a supply fan failure alarm. I was able to get that reset. Once I was able to get the RTU back online. So we got both compressors running. I do still have that return door open, so I do need to go up there and close that. That's going to get that supply air down. So far we're doing 1 inch of static. Now all the VAVs are wide open. It is given 100% fan command. So this says, inlet guide vane position. This has been converted to a VFD, by the way. So that drive, it does not look factory. I do want to take a look at this, but because we keep having that fan failure, it really makes me want to go in. I'm going to verify our fan status switch, which should be here close to the blower, and see if it's actually registering properly, or maybe it's getting old, worn, sticky, something, because this ain't no bueno. All right, so this is that safety switch I was telling you about. This should be our static sensing switch, and this is going to be our fan status. Now, one of the things I'm going to be looking at real quick is do we have any stopped up tubes? Are they real dirty? Anything of that nature that's going to be restricting flow, which I don't see. They all look pretty clear. So that being the case, my very next go-to is going to be, we might need to replace that switch. The day they replaced that drive, they had that supply air fan failure then. But in reality, that's expected because the drive was down. The fan wasn't going to run, so we were going to have a failure. Now, we shouldn't have had a return call on that failure, but we did, and that's what's interesting to me. I don't want to jump the gun and just start changing parts, but at the same time, you know, I don't want to keep having the same return call either. And this is not that, you know, expensive of a part. So, I don't know. While we're here though, so this is the old actuator that used to run those guide vanes. So all of these are locked into a single position now. They don't move or operate. They don't actuate. They're done. But as you can see, that's how they were controlling it at one time. And they converted it, so instead of running off of that actuator and this linkage right here, now they've ran it over, and that drive is what's controlling it, and it's running off of this relay. So I said this is the start stop. It technically is the start stop for the drive. And then if I'm looking at how they set this up, it looks like they're running this over to the drive directly, and the drive is, well, no, you know what, I'm just gonna waste time trying to think through this. I guess what they're doing is they're sending some kind of control signal from over here somewhere. I'm not sure where without just digging through this. Like I said, it's my first time actually putting hands on these units, but they've ran some sort of control signal over to hit that drive. It's not going to be a constant volume, and it can't be. All right, now we're not flowing air through our coil. Anyway, we're good there. Let me get this panel back on so that coil doesn't keep freezing up. Now, I need to correct myself because I'm sitting here really looking at what they did. I'm actually wrong. They're still using those guide vanes. They put that drive in as a soft start. So instead of just having a contactor or something closed and hit the motor and ramp the motor up and then run off of the vanes for static control, they are running the motor off of that drive. So I mean, it makes sense. You know, that's not uncommon for us to upgrade blower motors and stuff to soft starters. And that should be this circuit here going back over to the motor. So that's okay, you know. It definitely confused me at first, but that is what they're doing there. One of the things that I thought it might have been at first was a lot of times those on systems like this, if the static can't prove fast enough, it will trip on a supply fan failure then. But in reality, it's not because the fans actually failed. It's because all the VAVs downstairs are wide open. Normally on a system like this, you'll have your VAVs start off in more of a closed position at whenever the whole system goes to occupied, which gives your supply fan in the mornings a chance to build some static, and then the VAVs will start opening up a lot of the time. I don't know if that's actually the case here, but there are some buildings that require that. I was going into this questioning, did we have something similar to that here? I don't think we do. I think this system's fine. I genuinely think, being how this has reacted so far, that static switch is just intermittently tripping out when it shouldn't, because we'll get several days out of it without any issues, and then it trips back out again. So I am going to recommend, let's just go ahead. It's an inexpensive part. Let's just address that. We'll change it out. When we do that, we'll go through, we'll verify all of the static tubing, all the lines, make sure everything's okay, and then we'll get it we'll let it run from there and go from there.